All right, Brandon Clayton here, the Algebra Guy. Today I want to talk to you about subtracting integers in application problems. What is an application problem? That's a real life problem. Look, it's easy to do it when you're just having the numbers, right? Like 10 minus 5. But what if it's kind of embedded or hidden in a word problem? How would you handle it? So here's a type of problem we're going to work today. Leslie has $25 in her checking account and she writes a check for $8. What is the balance after she writes the check? So this is a real life problem, right? And a situation you'll come across when working your problem. So we want to be able to know how to do this. So let's get started with doing it. Let's first pull up our questions like we normally do and answer these questions. What are the steps to solving real world problems? Application problems involving subtracting integers, and how do I apply those steps in an application problem? So that's what we want to look at today. First, what is the plan for solving application problems? So if you saw the one for adding, it's going to be exactly the same. But it helps to have a step-by-step plan that you want to go through. Determine what we're looking for. Write a phrase to give the information that we're going to find. And translate the phrase into a math notation. Then simplify the answer and be sure to do the last step, which is rewrite it in the sentence so that it answers the question. So let's get to it and work in the problem. The temperature in Urbana, Illinois, one morning was 11 degrees Fahrenheit. By mid-afternoon, the temperature had dropped to negative 9 degrees Fahrenheit. What was the difference between the morning and afternoon temperature? So that keyword difference clues us to that this is going to be something maybe dealing with subtraction, right? Because what's the difference between these two? So here's our steps. First, we're going to ask we determine what we're looking for, which is easy because it's found in the question, right? So the difference between the morning and afternoon temperatures is what we want. And write a phrase that gives information to find it. The difference of 11 and negative 9. That's really what we're interested in. What's the difference between 11 and negative 9? As I go through these steps, just keep in mind, you may know how to do this already, and you can do this in your head or intuitively, so don't feel locked in as to go through step by step. But this is a great template to use if you're starting out and just getting used to it. Translate this into a math notation. So the difference of 11 and negative 9 would be 11 take away negative 9. So we can understand what the difference is between those two. Now, some would be tempted to say 11 minus 9 and get 2. But that's really not the difference, right? Because if you were to look at it on a number line, so let me draw a number line here. That's an ugly number line. So let me draw a straight line for a number line. Yeah, there we go. And so if this were, let's put my 0 here, and we got a difference of 11. So we started at 11, and we went down to negative 9. It dropped to negative 9. So to drop to negative 9, what was the difference? So the difference, the question we're asking really, if you're thinking about it visually, is we're asking ourselves, what's the space between this 11 and negative 9? All this space right here. So if you thought 2, because you said 11 minus 9, because you saw the 11, and you saw negative 9, which looks like minus 9, you might just think, oh, the difference, just subtract 11 minus 9. And you can be sure enough, if it were multiple choice, they would have a choice of 2 as a choice you could circle, because they know many students are going to do that without thinking, but you're different. You've watched this video and you know better than to fall for those traps. So you're going to say, no, we started at 11 degrees, is way over here on the other side of 0. Negative 9 is here. That was a huge drop. It went down 11 here, went down another 9 here. So that was a lot more than just 2 degrees difference. So now we're going to solve it. So that gives us 20. Well, how did we get 20? Well, you saw what we just did on this this piece here. Down 11, down negative 20. Down negative 9. So that was a total of 20 degrees difference. So we could put a little degree sign here since we're talking about degrees. But that was a total of 20 degrees. And if you remember our rules, anytime we have this minus next to the negative, we know that is the same thing as 11 plus 9. So that's how we can get our 20, because there's a difference of 20 degrees it dropped. Now, did it say minus 20? Well, because you could say it's going down 20 degrees, but they just want to know how many degrees difference did it go down. So the difference in temperature was 20 degrees. So we answered our question by putting it back in the sentence. All right, let's go to our next problem. And I want to do a couple more, and we'll close up here just to give us a good feel for how to solve application problems that have integers, and particularly subtraction. All right, next problem. Denise hiked from Mount Whitney, the highest point in California, to Death Valley, the lowest point. So you got the picture, right? So let me draw a picture. And I like drawing pictures. Sometimes when you're dealing with word problems, it just helps to have a nice visual. So here's our mountain. And it's at the highest point in California. This is Mount Whitney. Mount Whitney. You know, to give it some context. I even put some people in here, right? So you get the idea. So the elevation of Mount Whitney is 1446 above sea level. So this bottom part where it's on the ground, that's 0. So, but we know at the very top up here is 14,497. And the elevation of the Death Valley is 282 below sea level. My goodness. So below this sea level, so this is the water here. And there's a little fish. There's a little fish right there. That's a good little fish. Don't hate on my fish. That's a good fish. So this is the sea level right here at 0 feet. But below that, they're going way down. So I'm going to continue this thing. Let's say they weren't going in the water. Let's say they were going over here below sea level to this valley. And this valley is down here, and we're at 282. Let's say this is the sea level right there at this line. So let's say at the sea level. But this is 282 feet below that point. What's the difference in elevation from way up here to way down here at this point? I'm going to use a different color so we can be sure what points we're looking at. So at this top piece right here to this bottom piece down here, what's the difference in elevation? You can see that we're talking about this distance from sea level up, which is 14,000, and then this distance from sea level down to here. So all of this piece here we're looking for. So let's look at, let's break it down. What we determine what we're looking for. Well, I just said what we're looking for. The difference in elevation between the top here of Mount Whitney and Death Valley. Write a phrase that gives you information to find it. So the elevation of Mount Whitney minus the elevation of Death Valley. So really that's what we're doing. We're trying to take the elevation to subtract it from Death Valley. And if you want to put it in math notation, which you do, you're going to take the elevation of Mount Whitney, 14,497, minus negative 282 because it's below sea level. Now, the most important step, in my opinion, is this piece right here. Like, if you can think about this correctly, I'm going from the elevation to the valley, and then you can set it up a lot better. Elevation, I'm going to take away, subtract the difference in the elevation for the valley. And probably these two steps are some of your most important. Now, after this, we're just going to do the math. So let's simplify this. As we said a second ago, that negative, or minus negative, however you want to call that, these two are going to turn into a plus. So that's going to give me 14,497. Because I have these two next to each other, we've learned a rule that it just goes to a plus every time. 282. So really we're just adding. We're just taking the 14,000 feet here and adding it to the 282 here, and that's going to give us the total distance between the two. And when you do, you get 14,779. And now we say the right words to close it out. The difference in elevation is 14,779 feet. Let's do one more. Like I promised, here's our problem. Now this has 3 parts to it, but we're going to work them all. Leslie has $25 in her checking account, and she writes a check for $8. What's the balance after she writes a check? Well, somebody can be really technical here. Just because she wrote a check doesn't mean that her balance went down. So the question should have been asked better. After the check is cashed, what's going to be her balance? So let's assume they're talking about after the check is cashed. So she's starting with 25. We're looking for the balance of the account after that. 25 minus the 8 And you know how to do 25 minus 8, and that's going to give us 17. So $17 is our balance. So pretty simple, but it helps to parse out the different pieces in a word problem. Second part, she writes a second check for $20. So what's the new balance now? Well, first of all, let's go through our steps. We want the new balance. We take the original, which was a 17, is what we had left. This is not looking good for my girl because she only had $17 and she wrote a second check for $20. What's going to happen? I've done it before. Don't do it. Leslie, don't do it. I think she's going to do it either way. Actually, I know she is. So she did that, 17. She took away 20. Is that possible? You don't have $20 in there, Leslie. What are you doing? Well, the bank knows that too, and you end up with negative $3 in your account. Negative $3. But here's a side note. It's not going to be negative $3 because usually if you go below zero in a banking account, they charge you fees, $25 to $35. Don't ask me how I know, but they do. So either way, she's at negative 3 now. And so how are we going to answer that? She's overdrawn. So that's a word that's in banking you never want to talk about, being overdrawn. Oh boy, that's a painful reality there. So she's gone over her amount. So let's take care of this last part and look at how we resolve it. So she's overdrawn $3. Let's remember that. Leslie's friend told her that she had lost a check for $10 that Leslie had given her with her birthday card. What is the balance in Leslie's account now? So her friend told her, hey, you gave me a check for $10, but I lost that check. So she lost the check, she can't cash it. So let's talk about it. We want the new balance. So we want $10 more than negative 3. Woo! I thought it was going to be negative 3 after my friend cashed that $10 check, but fortunately, she's not going to cash it. So we're okay. It's not going to be $10. So I'm going to do $10 more than negative 3 because she's not going to be able to take that out. So negative 3 plus that $10 is going to give us 7. Because remember that our positive is bigger in this case when we're adding, so we know it's going to be a positive number. It's 10 minus 3 is 7. So we're going to rewrite this in the sentence saying that the balance is now $7. And that's how you would do it. Did we do everything? Absolutely, we always do. How can the addition of integers be modeled using counters? We showed, did we show counters? We didn't show counters in this one. Now I got to go back because, let me go back here because I always like to finish out with what we started. All right, here we go. We started here. Did we answer these? What are the steps in solving real-world application problems involving subtraction and integers? Yes, we went through the steps of how to do that. Those 5 steps, we use them each time. How do I apply these steps in an application problem? We showed, using those 3 problems, how you can actually apply them. So you are now ready to tackle your own problems. Again, my name is Brandon Clayton, and thanks for tuning in. I'll see you next lesson.